Greetings everyone. So today what we are going to be looking at, we are going to be understanding now some of the questions when it comes to electric circuit, right? So now please ensure that you have checked the past video where I was explaining in terms of some of the conceptual background of electricity in order for us to to be able to understand it. Now, so let's begin. So firstly, this question says, learners set up a circuit as shown in the diagram below. Now they say the EMF of each cell is what is 1,5 V, and each of the bulbs A and B has a resistor of 2 ohms, and bulb C has a resistance of 3 ohms. Right? So which means now you are given that here this your A and B consist of how many? 2 ohms, while your 3 this one consists of 3 ohms, you see. So now let's start here. So we are saying now, they say each cell consists of 1,5 volt. But how many cells do you have? It's 1, 2, 3, 4. It's 1, 2, 3, 4, right? So which means basically your voltage, firstly, your voltage is going to be equals to what? Your voltage is going to be equals to, it is going to be 1,5 V multiplied by 4, right? We're just ticking our checkbox. So which means the voltage that we are having, it's basically going to be what? It is going to be 6 volts, which is our voltage that we are having. So now then let's continue. So now let's look at our first question in terms of what it requires us to do. Now they say calculate the effective resistance of bulb A and also bulb B. Now, as soon as they say effective resistance, actually they just want you to calculate now what is going to be the total resistance of these bulbs, your A and B, right? So now we are going to say, isn't it that this is going to be your R parallel, right? This is your R parallel. And R parallel, remember, it is given by what? It is given by, it's going to be R of A multiplied by R of B, divide by what? Divide by R of A plus R of B. Now, which means this is going to be what? This is going to be equals to, now, what is your R of A? So they said both of them are 2. So this is same as 2 multiplied by 2 over 2 plus 2, which means now your R parallel is basically going to be what? It is going to give you 1 ohms. Are you together? It is going to give you 1 ohms. Now, so that's going to be your R parallel. Now, in 1.2, they say now switch S is now closed for a short circuit. So which means now they're saying this is closed. So now, and you know that as soon as this is closed, which means there is now a current flow within this particular circuit, right? There is a current flow. So now they say determine the value of your V1. So now as soon as this is closed, now your value of your V1, isn't it that as soon as this is closed, your V1, this is 1.2.1, right? So which means your V1 in this case is going to be what now? It is going to be this one, the 6 volts, right? This is going to be your 6 volt as soon as this is closed. Now, because remember, as soon as this is closed, your reading in your V1 is going to read in terms of what is the totality of your potential difference of all these 4 cells. Therefore, it is going to be 1,5 multiplied by 4, which is 6 volts, which is still the same thing, right? So now let's look at then 1.2.2. Now, in this case, they say determine the reading on V3. What is going to be your reading on V3? Now, so now, firstly, in order for us to be able to calculate a reading on V3, we at least need to know in terms of how much of the current is passing throughout the circuit, right? Because if you can know in terms of how much of a current that is passing through the circuit, then we can know what is our V3. So now what is it that we are going to do? So we are going to say, isn't it that we already know our R parallel? We already know our R parallel, right? So there are many ways that you can approach this this one to get our V3. So firstly, we can start by using the totality of our resistance. Remember, this is these two are in parallel, right? So which means you can add these two that are in parallel plus the one in series, right? So which means this is going to be, let's start with the resistor. So the resistors or the resistance totality is going to be equals to what? The ones that are in parallel, they gave us 1 ohms plus, you see they said it's 3, so it's going to be what? 3 ohms. So which means this is going to be your 4 ohms in totality. So which means the total resistance of this entire circuit is going to give you us what? It is going to give us 4 ohms. And then after that, we are going to now say, now to get in terms of what is going to be the reading on V3, you need to get in terms of how of the current, or what is the current that passed throughout the circuit. Remember that now the current, yes, here it is going to be divided, but as soon as it reaches back this point, it is then going to be connected again, or rather it's going to be a sum of the current that is flowing within these two bulbs, right? So which means therefore you can start by calculating what is going to be the current of this entire circuit, right? So we're going to say now I is equals to what? I is equals to V over our R, right? From Ohm's law, we are going to use our Ohm's law. Oh, we are still in 2.2, by the way. So now we are going to now say, what is your voltage? The voltage, we already know that this is 6V over what? Over 4. How to get? So which means the actual total current, what is 6 over 4? 6 over 4 is going to be same as what? It's same as 3 over 2 amperes, right? So which means actually your current is going to be what? It is 3 over 2, which can also be written as what? As 1,5 amperes. This is still just one and the same thing. How to get? Then now we continue. So now we are saying now we want our V3, so which means we are going to use now the same formula. But now in this case, remember, we just want to know in terms of how much of the voltage is passing through our V3. So we are going to just now do this way. We are going to say, yes, we have our current, right? We know what is the resistance of our bulb C, because your V3 is connected in parallel to your V3. So therefore we just calculate our voltage. So we are still using the same formula, right? You can say now in this case your V, or your voltage, is going to be I multiplied by R. So which means now what is your current? Your current, we said it's 1,5 multiplied by what is the resistance. Remember this, we are looking for our V3. So the resistor, we are going to use the C1 only, which is going to be what? Which is going to be 3. So basically now, which means the totality of this, it's your voltage is going to be 1,5 multiplied by 3, which is same as what? Which is same as 4,5. So basically the voltage in this is 4,5 volts, right? So your V3 is 4,5 volts. You see, now you need to have your physical science background in terms of understanding the circuit in order to answer some of these questions, right? So now let's look at our 1.3. So in 1.3, it requires us to calculate what is the energy that is going to be transferred in bulb C in 30 seconds if the current in the circuit is 2 amperes, right? So now what is it that we are going to do now? We are going to firstly understand what formula do you use to calculate for energy, right? Now remember, within a circuit that what helps us to transfer the energy, the electrical energy, it is what? It is the charges. So therefore, which means we are therefore going to use this formula of I is equals to our Q over change in time, right? So now let's see, what are we looking for? We are looking for our Q, isn't it so? So which means what we're then going to do, we are going to say now in a space for A, you're going to substitute this 2, which is going to be equals to your Q over your time. And what is the time? They said in 3 seconds, right? So this is going to be 3 seconds. So therefore, which means now your value of your Q or your energy, right? So your energy, therefore, it is going to be equals to 2 multiplied by 3, which is going to be 6 coulombs. Now that is going to be your energy that you are going to calculate. Now in 1.5, they say all the bulbs are now connected in parallel. How will the total current in this a circuit be affected? Write down only increase, decrease, or remain the same. Now, let's think about this very much critically. Now are connected in parallel. So now what is going to happen here is that now as soon as you connect all 3 of them in parallel, so remember already you had that your R parallel was 1. So which means actually it's going to even decrease more the resistor or the totality of the resistance in the circuit, right? And then now remember that you are having this formula. It's I is equals to V over R. Now, which means now they are inversely proportional to R. Your current is inversely proportional to R. So if now your R, your resistors are going to decrease, remember that if they are going to be connected, all the 3 of them are going to be connected in what? In parallel, which means they are going to even have the smallest resistance, right? So which means your resistance here is going to decrease, and as soon as your resistance here decreases, because they are inversely proportional, isn't it that current is inversely proportional, right? Which means if your current increases, your resistance decreases, right? So which means in this case, the resistance have decreased. Your resistance have decreased. So if your resistance have decreased, now your current is going to increase. So in this case, the correct answer is going to increase because current is inversely proportional to the resistance. So let's look at the second example now. Now here they are saying in your circuit below, so in the circuit, you are having V1, which is what? V1, which is 12 volts, and the reading on ammeter 1 is 2 amperes, right? So what is it that now are we required to do? Now 2.1 say calculate the total resistance of the circuit. So now this question, is very much critical. And now, in order for us to solve this question, we need to understand what is made up of our R total. Remember that your R total in this case is going to be made up of what? It is going to be your R parallel plus your R series. And as you can see that you're having a 6 ohms resistor that is connected in parallel with your 3 ohms resistor and your 4 ohms resistor that is connected in series from these 2. Are we together? So which means now we are going to firstly say, now what is your R parallel? Your R parallel in this case is going to be, isn't it that it is going to be your R1 multiplied by your R2 over your R1 plus your R2, right? So in this case, you're going to have what? You're going to have your 6 ohms resistor multiplied by your 3 ohms resistor over your 6 plus your 3. Now, what is going to be, therefore, what is going to be equals to 6 multiplied by 3? It is what? This is 18 over 9. So which means basically this is going to be a what? This is going to be your 2 ohms resistor. So which means your R parallel is going to be a 2 ohms resistor. So therefore your R total, therefore it is going to be what? It is going to be this 2 ohm resistor of your what? of the parallel connection plus the what? The 4 ohms resistor. Plus the 4 ohms resistor. So therefore, which means in totality, you are going to have 6 ohms resistors, which means your R total now, or your total resistance of the circuit, it is going to be equals to your 6 ohms, right? Now, let's look at now 2.1.2. Now here we are saying now, they're saying what is going to be the reading on your V2? What is going to be the reading on your V2? Now, this one, it is, very, very, very easy. So we're going to start here. Remember that in a circuit, in a series circuit, remember, as much as these two are connected in parallel to each other, but they are connected in series with your 4 ohms resistor. So therefore, which means the current that passes throughout this circuit, remember that within your circuit, your current, it is going to remain the same. Yes, it's going to come in here and it's going to be shared and divided, but as soon as they meet at this point, going to your 4 ohms resistor, they're still going to be what? It is still going to be your 2A. So therefore, which means now, if they are looking for a reading of V2, you have now your A and you have what? Oh, and then you also have your what? Your resistance. Therefore, you can calculate what is your V2. So you are going to say, now here your voltage is equals to what? Is equals to your current multiply by your resistor. So what is the current here? It is 2 amperes. Your current is 2 amperes multiplied by what is your resistance? Your resistance, remember, they are just looking for this one. So the resistance in this case is going to be 4. So which means your voltage is going to be 8 volts. So this is going to be the voltage that we are looking for, right? So this is therefore going to be your V2, which is going to be 8 volts. And ensure that in your questions, you always write the units because they are very much important. Now, this question now, say, they want you to calculate what is your A2. Now, firstly, in order for us to calculate what is our A2, which means we need to firstly know in terms of what is the voltage that is in here. Remember that now your resistors that are connected in parallel within a circuit, they are going to have what? They are going to share their potential difference, which means in this case, already you know what is your V2 and you already know what is your V1. So which means you can start by calculating what is going to be the voltage of this parallel connection, right? So which means you are going to say now, firstly, your V parallel is going to what? It is going to be 12 volts subtract 8 volts, right? So which means your V parallel is going to be 12 volts, which is this one, subtract this one. Subtract your 8 volt. And why are we subtracting here? Remember that the voltage in here plus the voltage of your parallel connection must still give you your 12V. So that's therefore we are saying your V parallel is going to be 12 subtract 8 volts, which is going to give you what? 4 volts. Right? Now that you know what is the voltage of the parallel, then you can go and calculate your what? Now we can go and calculate the ammeter reading in A2, which is your current. So you're going to say now, look, a current is equals to what? Current is equals to V over R. Now, do you have your voltage? Yes, you do have your voltage. It was 4. And what is therefore going to be the reading of your resistance in this case? So the resistance, because you are only just looking for your A2, so which means it is your A2 is just reading what is the current that passes through your 6 ohms. So which means here under resistance you're going to write the 6. So therefore actually your I, which is your current in this case, is going to be equals to what? Your I, which is your current, is going to be equals to this is going to be 2 over 3 amperes. That's going to be your reading of your current, which is 2 over 3, right? And this is 0. This can also be written as 0 0.67 amperes. Now let's look at 2.2. Let's look at our 2.2. In 2.2 they say, how will the reading on, in 2.1.4, which is what we are looking at now, they say the amount of charge that flows in your A1 through your A1 in 120 seconds. So they want us to calculate what now? The Q. Now remember that for us to calculate charge, remember charge is calculated in coulomb, right? So which means we are going to say now your 2.1.4 is going to be, I is going to be equals to Q over change in time. So in this case, you are going to say, you are looking for your Q. So which means if you make your Q, which is the charge, the subject of the formula, you are going to have what is your reading on A1. So I think it is fair that we actually start on having our reading on A1. Remember that now within that, they say the amount of charges that flow through your A1, that flows through your A1. So now if you are calculating the amount of charge that flows through your A1, your ammeter 1 in 120 seconds, so which means your Q is going to be equals to what? It is going to be 2 amperes multiplied by, what is the time? The time is 120 seconds, which is same as 2 minutes, right? So therefore, which means this is going to be 2 multiplied by 120, which this is going to be 240 coulombs. So your charge is going to be your 240 coulombs. Out again. So now let's look at 2.2. So in 2.2, they're saying now, how will the reading in A1 here be affected if the 6 ohms resistor is removed from the circuit? Now let me just draw this diagram. So this diagram is going to look this way. If your 6 ohm resistor is taken out, isn't it that you are still going to have your 2 cells, and then now as soon as they cancel your 6 ohm resistor, which means what you are left with, we are left with this 3 ohms resistor here. I'm just going to write the basic things that you need now, and then you are having your what? You are having your 4 ohms resistor here, right? So basically, this is more of how is the diagram going to look like, and this here being your A1, right? So now, can you see that your resistance now, remember the total resistance in this case was what? The total resistance in this case, it was 6 before, but now because you are going to have now your R series, can you see that your R series now it's going to be 3 ohms plus what? Plus 4 ohms, which is going to be greater than the 6 ohms resistor that we had in the circuit below before this was removed. So which means now your resistance is being increased. So if the resistance is being increased, then what happens to the current? Your current in this case is going to do what? Your resistance is increased, so your current is going to decrease. And why is it going to decrease? Remember, we've said it last time that now your current is inversely proportional, right? Is inversely proportional to your what? To your resistor, which means if this one in this case increases, this one is going to decrease, right? So that's the understanding why your resistance decreases, your resistance increases, and thus your current does what? Your current decreases. Now they say explain your answer without any calculation. Explain your answer in question 2.2 without any calculations. I've explained this. That now, firstly, now if the 6 ohms resistor is what is removed from the circuit, the 3 ohms resistor and the 4 ohms resistor are going to be connected in series in this case. Now if they are connected in series, what will happen now? The total resistance of the entire circuit is going to increase. The total resistance of the circuit will increase. Now, and as soon as the total resistance of the circuit increase, the current will therefore decrease, because resistance is what is inversely proportional to current. So that is going to be the reason why the current is going to decrease. So I've tried to explain, and now as soon as they say without any use of a calculation, they require you to use some mathematical, they require you to actually use some background knowledge to understand this, or to provide an understanding of this. Now let's look at also some of the example when it comes to electric circuit. Now this one, they're saying in the circuit below, the connecting wires and the battery have negligible resistance, right? They say now name the physical quantity measured by the voltmeter. So we know that firstly our voltmeter, now this is 1.1. Our voltmeter measures what? It measures your potential difference or it measures the voltage. Let's use the term of voltage. So it measures the voltage, right? So now number 2, they say to define the term resistance. So resistance in this case is what? Your 1.2. So resistance is the ratio. Isn't that the resistance is the ratio? Hopefully my spelling is still correct there. Is the ratio of the potential difference of the potential, it's 1T there, potential difference across a resistor to the current in the resistor. So that is a resistance, right? Or our 1.3 now. Now, firstly, in 1.3, 1.3 requires us now to calculate what? It requires us to calculate the equivalent resistance connected in parallel, right? So, which means we are going to say basically our R parallel, it's going to be your R1 multiplied by R2 over R1 plus what? Plus R2. Now this is going to be, therefore, give us what is your first R. Now the first R is what? It's 24 ohms multiplied by 8. Divide by what? Divide by what? 24 plus 8. And then now this is going to give us 6 ohms, right? So which means the R parallel is going to be equals to your 6 ohms. Now 1.3.2, they say now what is the total resistance of the circuit? So the total resistance, remember your R total of your circuit is equals to what? R parallel plus your R series. So which means in this case this is going to be what? This is going to be 6 ohms plus what is the one, what that is remaining? It is this 2 ohms resistor, which is also connected in series with these two. So therefore this is going to be plus your 2 ohm resistor. So therefore the totality of this circuit in terms of its resistance, it's what? It's at 8 ohms. Okay, so now let's look at 1.4. 1.4, they say when the switch S is closed, the voltmeter connected across 2 ohm resistor measures 6V. So they are saying this here, you are having your 6V here, the voltage here at 6V. Determine the potential difference across your parallel combination. So now you know that across this entire circuit you are having 12 volts voltage, right? Or 12 volts. So which means your R parallel is going to be equals to what? It is going to be your 24V. Now subtract 24V, subtract your 6V. Why is it so? Remember, because the voltage that passes through this circuit, or rather this connection, plus the voltage that passes through this connection, must in totality give us 24. So therefore this is going to be 24 subtract this, which is going to be 18 volts. So your R parallel is going to be 18 volts, right? So now 1.5.1 1.5.1 requires us to define what is the coulombs, right? So now so your coulomb is going to what? Coulomb basically is the current is 1 ampere when a charge of 1 coulomb passes through a point in a conductor, right? So coulomb is the current. So coulomb is basically the current, which is 1 amperes when a charge of 1 coulomb passes a given point. In a conductor. data in a second. Now, so basically this is your coulomb. Now let's look at basically now what is going to be our 1.5.2. Now they say now here use the data supplied in 1.5 and calculate the current in what in your 2-ohm resistor. So you are given that the charge you are consists of what 8 coulombs flowing through the battery in 6 seconds. So therefore they require us now to calculate current. Isn't it that our 1.5.2 isn't it that our current is what? It is the coulombs or the charges over your change in time, right? So this is going to be, what is the charge here? So the charge that flows through the battery you are given, that is what? This is 18 coulombs, right? Over now the time in a second, in seconds it's what? It's 6. So basically this is going to be 18 divided by 6, which is going to give us 3 amperes, right? Now therefore this is going to give us 3 amperes.